we saw how to minimize a machine using state equivalence, but the machine was a completely specified machine. The output against each input was available. The next state transition against each input was also available. Now what if the next state or some outputs are absent for the machine? Now that particular machine may be termed as incompletely specified machine, where outputs or the next state transition may not be available against some input. Here you can see that in this example, against the input I1, I2 and I3, the output is not available for this particular case. Against I3, if you are in state A, the present state is A, and you are giving input I3, then the next state is C obviously, but the output could be anything. It could be either 0 or 1. Now again, for this input I1, for current state B, what we are getting here is that neither of the next state or the output is given. So it could be anything. It could be either of the 5 states, A, B, C, D or E. The output could be anything of 0 or 1. Now such a machine is called incompletely specified machine. Now if an incompletely specified machine is given, how could we minimize? If we go on minimizing the incompletely specified machine using the previously considered approach by state equivalence, then it could give different it could raise different options. We can have different options in these incompletely specified spaces. So what should we do in this case? So the technical way of reducing this machine is by using a merger graph, then developing a compatibility graph using that merger graph. So first of all, in this tutorial, what I'm going to do is to develop a merger graph. We'll learn how to develop a merger graph, and then in the next tutorial I will develop compatibility graph and will ultimately reduce the machine. So first of all, what we need to understand what merger graph is. Merger graph is a graph where the number of vertices are equal to the number of states. Now if there are 5 states in the machine, now in my example we have A, B, C, D, E. There are 5 states, so each state corresponds to a vertex in the graph. So there are 5 vertices, A, B, C, D and E. Now what about the arcs? Now A and B, these two states are going to have an arc between them if they do not conflict for their outputs. That's the first condition. If the output for any input is different, then two vertices are not going to have any arcs. Now if the outputs for all the inputs are same, then what you need to do is to check whether the next state transition is same or not. If the next state transition of two vertices for all inputs are same, then A and B or Si, Sj are going to have an uninterrupted arc. Let us take one example. Now for this, say this D and E. For D and E, for all the outputs, here for I1 input you are having 0 output, it's 0 output. They are same. For I2 input, it's unspecified, we can consider it as 0. Here it is also unspecified, so we can also consider it as 0. That means they could be considered as same. If not specified, you can consider anything for your convenience. So we are taking a favor out of it. We are considering that the output is same for both the cases, and here for input I3 also what we are having here is the same output. So obviously D and E, they do not conflict as far as their outputs are concerned. Now what about the states? Now for input I1, it's C and C, both are same. Input I3, it's P and B, both are same. Input I2 not specified, we can consider same next state, taking favor out of it. So as far as D and E are concerned, their outputs doesn't conflict, they are having next state same. So D and E are going to have an uninterrupted arc between them. Now what about A and B? A and B, 0, we can consider 0 here, 0, we can consider 0 here, nothing, 0, so we can consider 0 here. So the output, they do not conflict. So what about the next state? E, here it could be considered E, B, D. Now look, Here the next state transition for present state A and B, they are different. So B and D are different. Here also C and B are different. So obviously for I2 and I3 their next states are different, but the outputs are same for A and B. So there will be an arc, but this arc is going to be interrupted arc. Now we are going to mention the incompatibility issue here. Why they are not compatible? Now there will be an arc because their outputs are same. Now we are going to mention that this is going to be an interrupted arc, and in the interruption what we are going to mention is BD and BC. Now it should not be CB. Now it's a tradition that we write the earlier alphabet earlier. Now you can write in this way for all the cases. If it is CB, change it to BC. If it is DE, it's DE, but if it is ED, change it to DE. Okay, so A and B are compatible as far as their outputs are concerned, but their next states are different for two cases. So if B and D, these two states are compatible, then only A and B are compatible. So A and B, their compatibility depends on the compatibility of B and D. Now later on we will be checking whether B and D are compatible or not, and B and C are compatible or not. If either of them is not compatible, then A and B is not also compatible. We'll be putting a cross here. So as far as this analysis is concerned, A and B are compatible as far as their output goes, but they are not compatible as far as their next state transition is concerned. Next states are different for I2 and I3, and we are in the interruption we are mentioning these two pairs of states. Now what about A and E? About AE, it's 0, it's 0, it's 0, it could be considered 0, it is not specified, so 1, 1, they are same. But E and C, so it's going to be an interrupted arc, and we are going to mention CE. It's not EC again, it's CE, mentioning the earlier alphabet first, then it's nothing here, it's BC. Okay, now what about AC? It's AC, it's 0, it could be 0, it's 0, 0, 0, 0, so it is also going to have an arc. So E, same. BD, this is different. So BD, AC is going to have an interrupted arc where we are going to mention BD and then it's okay. So if AC is only compatible if BD is compatible. Later on we'll be checking with that. Now AD, let us check AD. AD 0, it's 0, same, 0, it could be 0, 1, and it could be 1, and it could be 1, so it's an arc. So let us check the next state, EC. So it's going to have, AD is going to have an interrupted arc with EC between them, and then B, and then BC. Okay, now it's A and E, we have done A and E. B and C, between B and C it's nothing, so same, 0, 0, so they're same. Now their next state transition, it's same, it's not specified, so E, D, D, BC, it's different. So BC is again going to have an interrupted arc. It should be BC, the same thing. That means it is compatible if it is compatible, so you can ignore this BC. For the timing we are just writing. If something like this happens later on, we'll be ignoring this, because BC is always compatible if BC is compatible. That means it's recursive, so we can ignore this. BD. So what about B and D? it's not specified. 0 0 0 0, it could be anything. Same 0 1. So you can see that it's 1 and 0, they are different, the output is different, so B and D are not going to have any arc. Now what about B and E? B and E, it's not specified. 0 same 0 and 1, they are different, so B and D are also not going to have any arc in between them. So we have checked AB, yes we did. AC, yes we did. AD, yes we did. AE, yes we did. BC, yes we did. BD, yes we did. BD is not possible because 0 and 1, they are different. BE is also not possible because this 1 and 0 are there. And CD we did. CD, yes, it's different. CE, we have not checked CE, it's nothing, it's 0. Okay, it's different here. CE. So this is the final marcher graph that we have. Now we need to check whether all this compatibility are true or not. Now let us check. A and E are compatible only if C and CE and BC are compatible. Now we need to check whether these compatibilities exist or not, holds or not. Now BC, yes, BC is compatible. CE, C and E is not compatible. Since C and E, there is no arc in between C and E, so this is not possible. Again, AB is compatible if BD is compatible. Now BD, there is no arc between B and D, so this compatibility does not hold. Again, AC is compatible only if BD is compatible. Since BD is not compatible, there is no arc between B and D, so this arc should be crossed off. Now A and D is compatible only if, it should be written as CE, I'm sorry, it should be written as CE. A and D is compatible if only CE and BC is compatible. Now BC is compatible, CE is not, so this is not compatible. So here we are done. So this is the marcher graph. So amongst these 5 states, only BC is compatible, none of else are compatible. So let us take one more example. Before that, here is the conditions for which you should have an arc and you should not have an arc, and where you should have an interrupted arc and where you should have an uninterrupted arc. All these conditions are listed here formally that I have told you earlier. Now you can go through this, they are written properly formally. Okay, let us take one more example. Now, so this is the machine and we need to develop the marcher graph for this. So there are A, B, C, D, E, F, 6 states altogether. So there are 6 vertices A, B, C, D, E, F. Now go on checking one after another between the states. A, B, it's 1, nothing, so it could be 1, 0, 0, nothing, nothing, so they are same. So A, B should have an arc, but whether it is interrupted or not, it's E, same, B, same, E, C, they are different. So AB should have CE in between. AC, it's 1 1 0 0 0, it could be 0 0 0, so output is same. ED, so DE, BF, they are different. DE is different, so DE, A and C, it's DE and BF. Between AD, it is 1 1 0 1, this is different, not possible. AE, it's 1, it's 1 0, it's 0, it's same, it's 1, it's 1, then it's 0 and 0, so all are same. So we can have an arc between A and E. It's 1 nothing, 0 nothing, nothing, 1 0 0, but the output is next state is different. It's E, it's not given, B not given, A not given, same. So E and E. So between A and E, it is A and E. So we are not going to write A and E because it is the recursive one. Because AE is compatible only if A is compatible. It is trivial. It's always compatible. Now AF, it's 1 1 0 1. They are different. So AF should not have an arc. BC, it's same. DF no specified, nothing specified, so FA dash same. So it's an uninterrupted arc. BC should have an uninterrupted arc. BD, same 1 nothing, so same. So it's BD, nothing given, nothing, so it's okay. Same C, nothing, so it's again an uninterrupted arc. B and D. B and E, it's not given, 1, so same. 0 and 0, same. Output next state not given, given, so it's same. AC, so B and E is compatible only if A and C is compatible. B and E is compatible. B and E is compatible only if A and C is compatible. Now B, E is done. Now BF, it's not given, it's 1, sorry. Not given 1, 0 1, so it's same. Now about the states, it's not given B, not given C, not given E, C not given, so they are all same. B and F is an uninterrupted graph, uninterrupted arc. C and D, between C and D we can see that there are different outputs, so the arc is not possible. Between C and E, it's now between C and E, what we see that is this output is different, so between C and E we cannot have an arc. Between C and F, it's 1 1, it's 0 1, they are different, so we cannot have arc between C and F. Between D and E, we see that there could be there should be an arc because all the outputs are either not specified or same, so they're same. And the next state transition is also same, also to be considered as same. So DE is an arc, obviously. DE, there should be an uninterrupted arc between DE. Between DF, it's not specified, 1 1, it's not specified 1, same. So D and F should also have an arc between them, but it should be an interrupted arc because the state output transition and state transition is different. It depends on B and C. So DF, between D and F, it should be between D and F, it should be BC. Now between E and F, it's again same. You can see that between EF, it's AE. Between EF, it is AE. If the A is compatible, then only EF is compatible. Now we are done building the merger graph. We are done building the merger graph. Now we need to find out the compatibility pairs, the states which are compatible from this merger graph. As we can see that AB is compatible only if C is compatible. Now check that whether C is compatible. There is no arc between CE, so we should cross off CE. This is not compatible, so AB is not compatible as well. Now AC is compatible only if DE and BF are compatible. We see that DE is compatible and BF is compatible, so this is correct. AC is also compatible. Now BE is compatible if AC is compatible. We earlier checked that AC is compatible, so BE is also compatible. Now DF is compatible only if BC is compatible. BC is compatible, so DF is also compatible. Now EF is compatible if AE is compatible, so AE is compatible obviously, so EF is also compatible. So now we need to list the compatible pairs, compatible state pairs. Now AB is not compatible, AC is compatible. Now AD is not compatible, AD is not compatible, AE is compatible, so AC AE. Now BC is compatible, BD is compatible, BC is compatible, BD is compatible, BE is compatible, BF is also compatible. Now CD is not compatible, CE is not compatible, CF is not compatible, DE is compatible, DF is also compatible. Now EF is also compatible. Now for the triangle BDF, we see that BD is compatible, DF is compatible, and BF is compatible. So we can conclude that BDF is compatible. Now further we can go and reduce. We can see from the figure that for these four vertices BDEF, BD, BDEF, what we are seeing here is that it is forming a complete graph. So BD is compatible, DE is compatible, EF is compatible, and BF is compatible. BE and EF, this are also compatible. So what we can conclude from this is that BDEF is compatible. So we can reduce it further. AC is compatible, AE is compatible, BC is compatible, and BD, BE, BF, DE, DF, EF, all this could be written as BDEF as a single set. So this is the compatibility status of this machine M. Now that we have learned how to develop a marcher graph from an incompletely specified machine, in the next session we will develop compatibility graph from this marcher graph. Now using that compatibility graph, we can reduce these incompletely specified machines to further extent. That is our goal. We will be reducing the incompletely specified machine using the compatibility graph in the next session. Thank you for watching this video.